What we're going to look at today is dot product of when you've got three of those. Now, you remember how simple it was when we just had I and J? Think about when you had K as well, and you're going to do your dot product. It really doesn't change. It really doesn't. It's still going to be a number. Dot product will be a number, a numeric value, and you will still get it. But what it is, if you have got two vectors, and you're going to find the dot product, and they have three each, all you're going to do is add this one more component to it. All you have to do is where you multiply the coefficients of the two C's, coefficients of K. So V is equal to, and W is and I want to find my dot product. You still show it the same way. That raised dot, and it's going to be the two coefficients of I multiplied together, two coefficients of J multiplied together, and the two coefficients of K. Now, what is that going to end up giving you as a numeric value? It'll be 6 plus a negative 6 plus a negative 3, right? So what's that going to be? Negative 3, isn't it? All you're doing is multiplying your coefficient.
Is that a 3? What? At W? Oh, wait, never mind. Or 2.
Where, darling?
Is it 3I or 2I on W?
3I minus 2J plus 3K. Did you think my 3 was a 2?
Yeah.
So 2 times 3 plus 3 times negative 2 plus negative 1 times 3. This gets you your dot product.
How do you know the difference between this dot product and the one that?
Well, the only thing when we just had 2, it just didn't have this right here. Yeah. And the difference is you've got that third set of numbers you multiply together. Well, now, what do you think it'd be like to find the angle between those two vectors? It's exactly the same formula. Exactly the same. Has not changed one bit. So if I was going to find the angle between these two vectors, I know my dot product. I need the magnitude of V. Girls, you find the magnitude of V. Boys, you find the magnitude of W. The W is the square root of 22. What about the magnitude of V, girls?
Square root of 14.
So we've already found the dot product is negative 3. So to find the angle between them, put that and then put the product of the dot of the magnitudes. Now you can multiply these two together and have negative 3 over, and what's 14 times 22? 308. Now, what am I going to do to find the angle between the two vectors now? Just set up your cosine. Second, turn it on first. Second, cosine. And put in your, now you can do, remember you can do it either way you want to. If you want to do your like that. And what do you find your angle to be? 99.84. Did everybody get that? So we found the angle between them then is approximately 99.84 degrees. Now that procedure is not really any different than what we did when we just had two. Got a question? Okay, did you make sure you put your negative in? If you don't have your negative in there, guys, it will throw your answer off. So is everybody else, were you able to get that then? Okay, so what you've seen there is it's not really that much different, is it? Not really that much different. You're just adding, the formula's exactly the same. You just got one more step in each one of them. So that's not a big problem. We are not going to talk about the direction just yet. We're going to spend some time working on these. So I'm going to let you have some time right now on page 647, numbers 45 through 52. We'll give you a little bit of time to work on that in class, because the next thing we're going to do is going to take a little bit of time. Alright, remember when we first drew some vectors, and I just had it on grid paper and you just counted over and up and put them end to end and combined your vectors that way? Okay, we're going to look at dealing with force vectors. And this is doing like so many pounds of force at a certain angle. Okay, like for example, okay, let's say your Jeep gets stuck in the mud. Call a couple of your buddies to come over and help you pull it out. Alright? They may be pulling from two different angles, and each one may be exerting different force, depending on, their strength, their size, and that sort of thing. So you got these different forces working on whatever you're trying to pull, okay, whatever that object is. So what you got to do is you've got to figure out the resultant vector. Now these are force vectors because they've got magnitude and direction. Remember we talked about magnitude and direction before. Alrighty, and there's different ways you can have it written. So if we happen to have something like 100 pounds of force at 50 degrees, 300 pounds at 110 degrees. Everybody look up here how I've got this drawn. You're going to be drawing one in just a minute, so make sure you look at what I've done. Alrighty, you pick a starting point. You see how much this is like polar? You get your angle, 100 pounds at 50 degrees. I drew a 50-degree angle. Then I drew this vector. Since it has to be a certain length, I came up with a scale. And my scale, 1 inch, was equivalent to 100 pounds. So once I drew this line, 1 inch, where that happened, the end of that became that force vector. That was 100 pounds at 50 degrees. That force vector right there is represented right here by this. Then I was also applying this force. So what you do is you are basically adding the two force vectors. And you remember when we were adding them before where we just piggybacked one on the end of the other one? That's basically what we're going to do here. You go to the end of this vector and put your north, south, east, west crosshairs again, looks like a compass crosshairs, and figure an angle of 110 degrees. That's this. Draw that line, and it's got 300 pounds. Well, I had let 1 inch be 100 pounds. So if this is going to be 300 pounds, I made it 3 inches long. Okay? Then this became my resultant vector. So what I did is I took my little ruler and I measured my resultant vector. I got it to be 3 7/12 inches long, and each inch was 100 pounds. So I took my 3 7/12 and multiplied it by 100, which gave me 4,300 divided by 12, which would be approximately 358.3 pounds of force that was being exerted on that. Okay, now this is a way of combining force vectors. Okay, now the vectors we drew earlier were just over and down. You know, we drew some of those, but they did not have the same thing. All right, now let me give you one I want you to draw. Let's say I give you one, and I'm going to have you draw one that is 200 pounds of force at 45 degrees, and then 50 pounds of force at 60 degrees. I want you to take the paper you've got right there and your protractor. I want you to draw this, then draw the resultant vector, measure the length of that resultant vector like I did on here, and see what you think the amount of that resultant vector was. So I'm going to give you a few minutes to work on this right now. Thank you. Okay, sorry about that. Alright, guys, in order to find it, let's go back and look at what I've done right here. This one I drew, which is not the same one you drew, I found the end of my resultant vector. I dropped it straight down and across from the place I started. This became a right triangle. If I could get the coordinates to that point, I would be able to get the X and Y, or the horizontal and vertical displacement of that. Who feels like they have a pretty good drawing for this one right here? Alright, Jocelyn, let me see your drawing, girl. Okay. Do you all agree with what she's got drawn?
Yeah.
It was kind of a funny, skinny looking little thing, but it doesn't matter. She put a 45-degree angle. This was 200 degrees.
I forgot to draw that. It's 200.
Okay, this one was 200, which was 2 inches. 50 pounds, which was half an inch. This was the resultant vector. Now, if any of you all know how to do this better than me, you can come up and teach. Otherwise, I best get your total and undivided attention. Okay? Because you can measure it. She measured it. Got to be 2.5 inches long. Since 1 inch was 100 pounds, she got an approximation of 250 pounds. Okay? Did a lot of you come up with that? I'm seeing some yeses and some no's. Alright, I'm going to show you how to work it out and get the exact value, and then we'll compare it. Just leave it right here. Here, take this. You might want to write the notes down on it. Alrighty. In order to find our horizontal, you might want to be taking these notes. The horizontal displacement. In other words, how far the terminal point on yours is, final terminal point, is from where you started. The horizontal displacement is the amount left or right you go to get to that. So to find your horizontal displacement, you take the pounds of force times the cosine of the angle, add the other one to it. Okay, put that in your calculator right now, guys, and tell me what you get the horizontal displacement to be. 166.42. Everybody in agreement on that? Yeah. Okay. Now we're going to do our vertical displacement. Now in vertical, going to be up and down. Think about it, isn't that going to be your sine factor sine? So you're going to have 200 sine 45 degrees plus 50 sine 60 degrees. And what is that going to give you?
Wait, so what is the
horizontal? Horizontal is how far, this point is how far you go left or right, and then you're going to go up or down to get to it. The horizontal is how far you go left or right. Now we're getting the vertical. So what do you get the vertical to be? 184 point what? Okay. Let me borrow yours again, Jocelyn, and I'll show you what I'm looking for. What this is saying is basically, if I took this final place she got to and I dropped it down, and made a right triangle, this would be the hypotenuse. Okay, finding your horizontal and vertical displacement. The horizontal displacement is saying that this right here is 166.42, and this height is 184.72. Well, it's going to be a lot closer than your drawing, because these drawing tools we use, guys, let's face it, they're not the most precise, cutting-edge technology. These protractors have been around 100 years, I guess, so I mean, you know. Now, let's go ahead now and figure how you would find that hypotenuse. So the length of that resultant vector would be the square root of squared plus the 184.72 squared. Now somebody tell me what that's going to give us. 242 point what?
I got 248.
Yeah, I got 248.63.
Okay, I guess I just didn't hear good. Alright, that's pretty close to your 250. Now guys, this is more accurate. This is more accurate.
So what do you want us to use if we have a question?
If I ask you to draw it, I want to know that you know how to draw it. But when computing it, I would think this is going to be your most accurate. Now what you can do is you can kind of estimate from your drawing and use this to verify, and they should be close. If one is really funky looking weird from the other one, then someplace you're off, and you probably need to. But do you see what this is doing? Jocelyn, let me borrow this again. Borrow yours again. I should have just drawn it. Yes, Catherine.
For my answer, I got 100.
Did you get these two values?
No.
Okay.
Like, whenever I drew it myself, I got it. And I got 100.
Okay, I'll tell you what, I'll come and look at yours in just a minute. Let me ask you something. I'm sorry, Jocelyn, I'm messing yours up big time. I'm gonna use this green, and I'm gonna highlight that green as the resultant vector. You know, we said that vectors have both magnitude and direction. Okay, oh yes. This got our magnitude. Now let's use some common sense, guys. Once we've got these two values, the angle from here over to the resultant vector. Now look at that, guys. What would be the most logical, quickest way to get that? What did you say, dear? By far, the quickest way to get that angle would be tangent of theta, since we know opposite and adjacent is and what do you find theta to be?
47.98.
Isn't it a little bit bigger than 45? Doesn't that make sense? It makes sense. Alright, now tomorrow, guys, we are going to do some more of these. If you have graph paper at home, bring it, okay? Because we're going to do some more graphing. Your homework tonight is to finish up those problems you started before we left for lunch. Finding the dot products and the angle between them, and we're going to work on some more of this tomorrow.